we have integral of rational fraction. First, we need to check degree of numerator and denominator. Degree of numerator is invisible 1 and degree of denominator is 2. So, is less than degree of numerator. Next, we have to look if we don't have in numerator derivative of denominator. Derivative of denominator will be 2x minus 4. We have different numerator. So next step, we can rewrite our rational fraction. Let me copy this. We have x plus 13 over x squared minus 4x minus 5. This is equal. We see that we can factor denominator as a product of linear factors. Numerator, we have to just copy x plus 13, and denominator we can rewrite as a product of linear factors. So because we have x squared, so at the beginning will be x. And now we have to find two numbers which multiplying give me -5, and when I add them I will have -4. This is -5 and 1. Let's check. When I multiply -5 times 1 will be -5. And when I add -5 plus 1 will be -4. So now, in case like this, where the numerator has a smaller degree than the denominator, we can write the given rational fraction as a sum of partial fractions. So let me copy our right side. We have x plus 13 over x minus 5 times x plus 1. This is equal. When we have linear factors in denominator, let me write this formula here. When we have linear factors in denominator, x plus a times x plus b, we will use form of partial fractions as a over xa plus b over x plus b. A and b are constants. So now, in this example, we can rewrite our fraction, rational fraction, to partial fractions, and will be a over x minus 5 plus b over x plus 1. Now, to reduce denominator, we will multiply both sides our equation by x minus 5 times x plus 1. So let me write this. We multiply both sides by x minus 5 times x plus 1. We can reduce x minus 5 and x plus 1, and we have on the left side x plus 13 is equal, will be a over x minus 5 times x minus 5 times x plus 1 plus, and now we have to multiply the second partial fraction by expression x minus 5 times x plus 1. So will be b over x plus 1 times x minus 5 times x plus 1. So we can reduce denominators, and we have that x plus 13 is equal a times x plus 1 plus b times x minus 5. Next, to find a and b, let's put that first x is equal -1. So we will have on left side will be -1 plus 13. This is equal 12. And on the right side we will have a times -1 plus 1 plus b times -1 minus 5. So this is equal -1 plus 1 will be 0, so 0 times a will be 0. And we have b times -6. Because the left side and right side should be equal, so we have equation b times -6 should be equal 12. So we can divide both sides by -6, and we have that b is equal -2. We have b. Now we need to find a. So let's put that x is equal now 5. So we will have on the left side will be x will replace by 5. So will be 5 plus 13 is equal 18. And we have on the right side, we now have to replace this equation x by 5 on the right side. So will be a times 5 plus 1 plus b times 5 minus 5. We see that 5 minus 5 will be 0, 0 times b will be 0. So this expression we can reduce, and we have a times 6 only. Left side and right side should be equal. So we had that a times 6 should be equal 18. We can divide both sides now by 6. So 6 and 6 we can reduce, and we have that a is equal 3. We found a and b, so we can rewrite our rational fraction to sum of partial fractions. And we will have x plus 13 over x minus 5 times x plus 1 is equal, we have a, so we will replace a by 3, will be 3 over x minus 5 plus b is equal -2, so it will be -2 over x plus 1. Now we will come back to our integrand, and we can rewrite this integral. Let me rewrite this. We have x plus 13 over x squared minus 4x minus 5 with respect to x. This is equal to sum of these two partial fractions. So we will have integral of 3 over x minus 5 plus -2 over x plus 1 with respect to x. Integral of sum is equal sum of integrals. So we have integral of 3 over x minus 5 with respect to x. Positive and negative give us negative, so it will be negative sign before integral, and we have 2 over x plus 1 with respect to x. We get very easy two integrals. First, we can put this constant before integral, so this is equal. We have 3 integral of 1 over x minus 5 with respect to x minus, and we will take this 2 before integral symbol, so we have 2 times integral of 1 over x plus 1 with respect to x. This is equal. We see that in numerator we have derivative of denominator, because derivative of denominator will be 1. Because derivative of x is 1 minus derivative of constant is 0. So 1 minus 0 is still 1. So we have in numerator derivative of denominator. So we can use formula that integral of, in numerator we have derivative of denominator. This is equal natural logarithm of absolute value of f of x plus constant. So we will have 3 times natural logarithm of absolute value of whatever is in denominator. We have x minus 5 plus constant, and we have minus 2 times, and again we have in numerator derivative of denominator. So we can use this formula one more times. So will be 2 times natural logarithm of absolute value of x plus 1, and we have to add constant, now c1. So this is equal. We can combine constant, so will be 3 natural logarithm of absolute value of x minus 5 minus 2 natural logarithm of absolute value of x plus 1, and constant plus constant give us constant, so I can put C2. This is my solution.